Today, we get to have a conversation with two engineers from Idea Statica. Lucky for us, we ran into this group at the Steel Conference and got a chance to speak with them behind a microphone. Andrea and Johan have an exciting combination of experience. From traditional structural design and tension structures, cool, they made their way from the designer to the team designing the tools. We had a big category of questions from what makes a great connection and the logic behind that, but also the transition from practicing structural engineers to sitting behind software that helps make great designs easier. If you're thinking about moving into the computer side of structural, or if you've ever designed a building with a connection, I have a feeling this one's for you.
The Structural Engineering Podcast.
Well, thank you both for joining us on the Structural Engineering Podcast. We're sitting here today in a very odd room deep in the conference. We're so excited to sit down with both of you. To start us off, would you mind introducing ourselves? And we'll start with you, Johan.
Definitely. My name is Johan. I'm a product engineer for Idea Statica. I've been with the company for about 3 years, a little bit over 3 years now. And it's been a fun ride. I enjoy what I do and I love helping all engineers, different professions. So liking it.
Yeah, that's awesome.
All right. My name is Andrea Casello, and I'm also product engineer. I have 4 years in the company.
Okay.
This job, I like it a lot. As Johan said, it's like helping engineers, knowing a lot of type of projects that they are doing with our software. It's great.
You can see the value of doing the software side. Like you're touching so many projects and making the world essentially. That's very exciting.
Yeah, this is a totally new world to Max and I, as we've both been practicing engineers and, have never really been on the other side of things, and from the connection design especially. So kind of framing where we're going today, would you mind also kind of walking us through your career to this point, from where you went to school to how you got to where you're at?
Yep, definitely. Well, on my end, I've always stayed kind of local to where I've grown up. So, from Dallas, I went locally to university, UT Arlington, so about 30 minutes from where I live. But yes, that's where I got my bachelor's of engineering. I'm specifically a mechanical engineer. Not your typical.
Left-handed now.
But definitely, I mean, this is not the specific profession that you would see, but definitely it was worth it. There's a lot of intertwine that I get to learn for civil engineering, for statics. But right after that, I started a job with a shade structure company. The company is USA Shade. They're basically the biggest shade structure company in the nation. I would say international as well. And it was a very good learning experience with them. I basically was everywhere. I started with value engineering, so kind of helping them optimize their products, see where we could, make savings. Is not the best, right? As an engineer, you kind of get
efficiency is a nice word. Where you get efficiency.
Yes. That's a better word that we would like to call it. But then, afterwards, did some design and engineering. So I got into learning more about how to create detailed drawings for them, making sure everything was detailed specifically, because within the company that I was, we were very lucky to have our shop behind where we were at.
Very nice.
So we were in contact with them a lot. So we had to make sure that, the fabricators or the welders, they were being able to read their drawings correctly.
Yeah.
Then after I got that experience, and I moved on to the structural part of the team, and that's where I learned Idea Statica. I learned about the different software, RISA, RFEN, basically the software that's more in line with tensile structures, being able to model fabric and everything like that. But afterwards, that's from learning Idea Statica. That's where I was fortunate enough to be with the software now.
That's exciting. I've done a lot of the career fairs and run into a ton of mechanical engineers. And usually they say, hey, I want to do rockets. I want to do race cars.
Right.
In your mechanical background and where you're going with school, where do you think that would lead?
Initially, I thought, I was always driven to with the software analysis. So whenever I was in mechanical engineering, we learned about Abacus, ANSYS. So sort of the more complex software. But for structural, these are too complex because you want to analyze, certain connections, but not spend too much time modeling everything from scratch. Exactly.
Yeah.
So when we were able to find, at the other company when we found this software, it was, cherry on top.
Yeah.
Basically being able to model things at a faster pace, being able to get results, analyze them, and be satisfied.
Yeah, I feel like engineering school is problem solving, and
Exactly.
whether it's mechanical or structural, it's the same. Get to the bottom of the challenge. So
Yeah, you get taught the fundamentals, being able to, look for solutions, look at the problem, analyze it, and be able to find that solution.
that's exciting.
Yeah.
Yes. Fun fact is that when I learned that Johan was coming to the, he was kind of interviewing, I was reviewing the cases. That's what we call our tech support tickets. So, so he was a user. He was asking for
A lot of cases.
That was fun.
I know. Before I joined, I was just like any other regular user, checking out for help.
Exactly.
It's like, these questions are so good. We have
Yes.
Like, you go into the cases and see, like,
I think I'll be okay.
I was asking.
The reflection. That was a bad question. What was I thinking?
What was I thinking? I should have done my research, right? Yeah. Exactly.
That would be super fun. Should go back to your cases. You have time, right? I'm going to go.
Yeah,
through my...
absolutely. Yeah.
Go for it.
No, so I am born and raised in Mexico, so that's how you say it, guys. So I studied there in Mexico all my life, and then I did a bachelor degree there, or like in my small town where I lived. It's called Cuernavaca. It's close to Mexico City. So I studied there. Then I started, like, after my bachelor degree in a kind of consultancy engineering construction company. They were doing everything. So I was doing like structural design. I was going to the construction site to review that everything was constructed okay, doing bidding processes and all that stuff, all that fun stuff that you do there, right? And then I applied for a scholarship, so to study like abroad, and I got that scholarship from the Mexican government.
Cool.
Went to the UK.
Wow.
Abroad. Yes, yeah. So I did a master there for civil engineering, but you can that was so cool because you can pick and choose your classes. So the master degree is in civil engineering, but basically I selected all structural engineering.
Good choice.
Structural
Yes.
and geotechnical engineering.
Wow.
It's that part of your career that you don't really know what to do.
Where you'll land. But
Go.
Yeah.
But I like structural engineering and geotechnical engineering, so I was doing everything. Then after that, I wanted to stay there, like to just keeping this, like traveling thing and, living abroad and having this experience, speaking in English, having all my engineering in English. But I called him, I didn't get the job. It wasn't that easy to get a kind of a sponsorship. And
that adds another layer to be promised elsewhere.
Yeah, and then I came back to Mexico and kind of frustrated a little bit, because I was living outside there and then coming back to my parents' house, and it's kind of frustrating. But then for some reason I got into a Bentley job position. So it was like the first time that I didn't know that this type of job exists for structural engineer, right?
Yeah.
So so I got that job, and then I was application engineer, something like I do now, but for the Bentley products, and that's how you call it, application engineer. And I learned StatPro, RAM elements, RAM structural system, RAM connection. So I was the expert for that. But for LATAM countries, like for Mexico and all the LATAM, Latin America countries. So that's my experience with Bentley. I was doing also kind of a little bit of tech support for the US. So I was starting to learn a little bit of how you do things here very differently. So I have this type, kind of international experience. just because I went to the UK and I was doing Eurocode.
I know nothing of this.
Learning that.
Metric
and then,
system.
yeah. And then...
Maybe better. I don't know.
My precise.
And yeah, so after that, it's like, okay, I need to move on. Like, I wanted to
didn't
move on
feel like a
because
permanent.
like mentally super a big company.
Yes.
It's hard to, like this, going advancing on my career there. And I was like, oh, I'm feeling a little bit stuck. So it's like now or never. So that's when I started to look for opportunities here in the US or abroad, whatever. I got this interview with Idea Statica. It happens that they were starting to create the office here. So, or the branch, let's say. And yeah, I mean, I got it, and I moved from Mexico City to Philadelphia for the job.
Yeah.
It was great.
How long has the U.S. been, a part of Idea Statica?
For 5 years. 5 years.
Okay.
Yeah.
I want to ask for people that are listening and would like to work in the software side, did you do any software engineering or anything that leans towards computer science when you were in school, or is this kind of adapting now?
No, not really. Like, I didn't do anything like related to software engineering.
Yeah.
Like just your regular C,
Excel program.
or C++, classes that you get, and that's it. But nothing like special.
Okay. Yeah.
Well, from your grad school days, I think going structural engineering and not geotech was probably a good idea. We had dinner with some engineers last night.
Yes.
And the whole conversation was geotech's just voodoo magic, and that structural engineering is nice and simple.
Very precise.
And precise.
Geotechnical is like you need to be almost crazy. Too many things.
Okay, so getting into connections a little bit here, but setting the groundwork. So I think as an industry, we often think of connections as the last piece of the puzzle, right? Like you put this whole building together and like, oh yes, the beams have to attach to each other. This will be the last piece. Now that you've been in the Idea Statica world for a while, do you think about connections differently? And like in the global design of a structure, do you think about connections earlier? And can we take anything from the way you think about connections here?
From my experience and working on the, shape structures, connection design was actually an early adaptation or something that we would look into early on. Because these type of structures, you have to rely on the localization rather than the global. Because if that connection is failing, then you have to upsize your members, you have to go back and reanalyze your global analysis, input your loadings again, and reanalyze everything. So from the get-go, kind of on the initial analysis, we would have to look into, potential changes in the connection, potential changes in the structure, just to be able to get everything from the start. Because if you have to reinforce your connection or adjust your connection or your structure, it's going to eventually affect the customer. The price is going to go up a lot. So
carries down a while.
Exactly. So that's something that we will look into early on from my perspective. Andrea, I'm not sure if you have any.
Yeah, definitely change your perspective. Like it's something you need to look at before, like at least at the same time as you're kind of framing your structure, I would say.
I have a lot of questions on the tension structures, so glad you brought this up. But like, I think tension structures really indicate connection and like the formwork of an item. Connections are, in my thought, more important in a tension structure versus a gravity-bearing condition. Do you think starting your career there shaped how you think about connections differently? And can we take anything valuable from there?
Definitely. I mean, like you mentioned, in tension structures, connections is one of the main pieces of the puzzle.
Yeah.
Just because it also helps with the erection process. So tension cells or shape structures are more like Lego pieces, I would say. You want to be able to make erection a lot easier. So either working with bolted connections, or if the customer wants a very aesthetic structure, that they might not want to have those connections be shown. So that's where you have to lean into whether do you want to make this structure easy for the erection, or you want to have it for the aesthetics. So, you might have to sacrifice.
Choose one.
Exactly. Either a bolted connection or field welding. So that's where, the customization will come into place. So that's really changed a lot. So like, let's say whenever a customer wants a very aesthetically pleasant structure, you might opt into hiding the connections. So one of my favorite connections that I've seen for tensile structures are called Diablo connections. Diablo connections.
Yeah. Okay.
Diablo, yeah.
Yeah. So these are kind of splice connections between members. And so instead of having the bolts exposed in the structure, they're kind of hidden inside
Yeah.
in a way that makes the structure be
Look sleek, cleaner.
There,
Yeah.
exactly. So that's how it's changed my perspective, I would say.
From like a big picture, what do these shade structures look like? What pieces and parts are kind of traditional to them?
Well, I mean, anytime I talk to anybody about shade structures, the first structure that comes to their mind are canopies. That's the main
Oh, yeah.
I have a
structure.
canopy in my yard.
Exactly. So those typical connections you'll run into are your rafter connections, your cross pieces, the common base plate connection. It's all HSS. But you could get into very customized shade structures. I know my last big project that I had for USA Shade was a shade structure that was going into an amphitheater. I believe it's for UC Irvine. And it involved regular skewed connections, but also we had to build a truss for that tension cell structure because that the span for the structure was very big to be able to accommodate the amphitheater. So you not only get into the regular shade structure connections, but you also have to build in some more customized structure. So that truss was pretty complicated, and then having HSS into it. So with the span, with the curvature, it becomes a lot more complex than regular.
I imagine with the shade structures, you really have to think about the bending of a beam, like in your truss. If this bends quite a bit, your shade structure is now sitting flat or like not tight anymore.
Exactly.
So
we
deflection matters.
There you go. And we also have to think into what's possible in the shop. Well, our limitations. Sometimes a customer might want a very long span beam, but that might not be possible in the shop, so we have to find other ways to be able to either outsource it or cut the connection or the member at a certain specific length and connect it another way.
Wow.
Going from shade structures, what pulled you from like a traditional style structural engineering into software, basically? Like it's a different problem approach, obviously, and I'm just curious, was this something that you were interested in early on, and what made you make the switch?
Yeah, so as I said, like when I started in my case in Bentley, it was kind of just exploring what were the options for me, and I mean I like it. It's not that I was thinking like I'm going to do this switch. It was like just my first like very very official kind of job. So that's I started there. So it was there is no different option. But when I started there, and I saw that you don't have to stay late to, like the leverages are finishing.
Every listener.
So I was like, maybe I like this. Because before when I was in this small company at my hometown, there was like crazy things. Like you had to wait or, like to stay late to finish something because they were waiting for you. So when I was like in Bentley and like 5 or 6 p.m. is starting my day on Friday, and there you go. It was something that I was like, okay, maybe I like this. But obviously you have other challenges that is like learning so many things because you are involved in so many like so many different types of structures. So there's no specific thing, so you need to keep learning. You need to learn how to communicate with engineers, and that it's not
still working on that one.
It's not that easy, Like engineers, we are not that easy. I mean, we have this type of skills just because we are in this job, but with engineers, it's hard to communicate. You don't really know what they're thinking. You don't really know what they want to say, and anyway, but I think it's normal, right? How people behave. But so there was no like thing that I wanted to switch from. But I
But
just got
felt
into
natural and
it's super natural.
What is it like getting onboarded into a software company? Like, are they sitting you down, going like through the code? Here's how we
No,
pitch this to
definitely. Like
people.
if you're behind the scenes, like in the development team, probably yes. You need to go inside.
You have to know
like,
everything. Yeah.
review the entire code. But no, for me, it's just like learning the software.
Mhm.
You know, start doing tech support cases, and that's where you start learning the software
Can
because
imagine.
they find like the very specific error in the software,
Yeah.
so they'll find it. I'm sure.
Oh, yeah.
You'll get all personalities.
Yeah, basically it's learning the software.
Yeah.
Like from top to the bottom.
Yeah. So what would you guys say you've learned from I'm just thinking of many engineers, structural engineers I know are very excited about finding things that are right and wrong, mostly wrong.
Yeah, exactly right.
You're dealing with a lot of different personalities. What tools do you guys use to effectively communicate with them? You just push back the same way. This is wrong. You're wrong.
We just try to, guide them the best way possible and just try to understand where they're coming from. I mean, a lot of users are only there to get what they need and not explore past what the application can offer. So a lot of times it's just guiding them and teaching them the right ways of the software. But we try to be as proactive as possible, I would say, whether we can get on calls with them, talk to them, or just email, or maybe some training videos we will send to them, and we try to get the best feedback possible.
Yeah, I can imagine, and I would expect this of myself, is I'm solving the problem this way, and the software isn't working right at this point, and getting stuck on the same path if that's not the way I should be solving this problem. Like larger training on the whole software, not doing it this specific way that I feel like should be right when that's not how it works.
Exactly, and one of the things about our software is there's many ways to get the answer. You know, with FEA you can build any connection differently, but still get the same results. So it's all about finding the most efficient way to do it rather than doing the typical way where you can spend a lot of time making a connection. But if you find better ways, why not try?
Yep, I like it.
So I often think that we go from kind of high level engineering, our first principles and things, and then we do our engineering in either programs or by hand and things like that. And then we get into connection design. Mostly that's within software. How do you feel that the software helps the engineer from that engineering judgment standpoint, being able to, use their gut to verify things, or how do you see that working out?
Well, I would say within the software, you get a better understanding of kind of, you transfer forces, the way that the stresses are being distributed along the entirety of, your connections. So by being able to visualize and look at the deformation of those connections, you get a better feeling and a better understanding of what needs to be done or what are the next steps, whether you need to reinforce your connection, you might need to take a step back and look at your members. Are they actually being fitted correctly? Are they the right size? Rather than going with your regular hand counts, you don't really get to see what exactly is happening. You're just looking at your formula results, whether it met the criteria or not, and idealize kind of assumptions exactly.
Yeah, I think with idea statica, it's not like I'm talking all about the idea statica, but we're doing this kind of change of the way connections are designed.
Yeah.
Why? Because all the engineers have this other products that they basically have this code equations like program.
We program these in our head.
Yes,
it's like we know this beam has this many bolts 99% of the time, and we look at the table.
Right? Compared to global structural software where you apply the loads and then your first thing that you do is you look at the deformation.
Yeah.
And you feel fine with that. Like it's your first step, right? With connection design, I think people haven't done that before. like looking at the deformed shape. It's kind of weird for them because they are not used to that. They just type some numbers, like, as you said, like the size of the beam, the thickness of the blade, and it's okay. You have
the limits.
I see a green box. It's good. Yeah.
And then with idea aesthetica, because you can look at this, the form, shape, or the formation of the, like the model. It's kind of weird. I have seen some people like, why should I see this?
Yeah.
Right? But it's because it's not normal. So we are kind of educating people, to start.
Yeah, definitely.
That. And it's kind of weird sometimes. Like it's just go and see it, because you do the same with your structural analysis model, and you see all that, and it's normal for you. Why would you do that in the connection design? So it's really nice to be, like within that change, kind of changing the industry a little bit, maybe a little bit, but it's a change.
It's such a good point. I didn't even think about that. Like, especially young engineers, I'm like, how does the deflected shape look when you're making this model or something? And, that kind of validating that way. Is it acting the way we would expect? But didn't even think about that from a connection standpoint. It's not something that's intuitive. It's something you're looking at, but having that is probably really helpful.
Yeah.
Stresses in a plate or whatnot, like, are harder to picture than a beam bending a simple span. Like,
right.
It's a different graphic in your head.
Yes. And it will, that they will change if you have different type of connection.
Yes.
So you are expecting
I know that, but I don't think I would think about it. Yeah.
Exactly. You're expecting something, but you're seeing another thing. So,
Did moving into software, you change how you think about structural engineering? Like talking about you speaking to people and like the connection design needs to look like this, the stress distribution or deflection. Does talking with engineers change how you think about structural engineering and the software?
Yes, definitely. I mean, when you're designing, when you're in the like doing design for a structure, you're not thinking of all the tools that are available there you can use for that, However, in the other side, the software very well. Like for me, like when I was in Bentley using StatPro or RAM elements, all the possibilities you have, right? So you are not missing any of them because every piece.
Yeah, you have your process in your head, and
And when you are in the other side designing the structure, you just need to finish it, and you just need to comply with like certain
code issues,
equations, and there you go. So the way, like all these tools that are available outside gives you another like way of doing things.
Yeah.
And a better way of doing things, but you don't know. And how can you like kind of push the user to use all the tools?
Yeah.
You cannot do that. So it's to them. Like,
that's right. Yeah. We'll do it the way that we're used to, unfortunately.
Yes. And
Yeah. I got this abstract connection question here, but
let's hear it.
Yeah. How would you think about connection? Yeah. Like, what makes a connection feel clean to you? Like, this connection is perfect. If you see a connection, like, that is exactly what I expect the connection to look clean and precise. What is that? What triggers that?
To me, I would say a connection that will feel clean would be one that does not contain too many stiffeners, I would say. That's something kind of indicative of that there might have been issues, or that maybe the design process was not well thought of, because if it was, then there might not be a lot of need for to stiffen up your connection to add different replacement parts, things like that.
Yeah.
So to me, a connection having little to no stiffeners would be part of a clean connection.
Yeah.
Okay, I like that.
I mean, I know that welded connections are difficult to construct on site and so on, but I like the welded connections.
But you got
look very nice.
Yeah, exactly. But I know that it's difficult. Yeah.
I'm curious now, being in the world of connection design, does everywhere, like Max and I landed yesterday here in Atlanta and saw this beautiful structure that kind of covered the drive-through area and stuff.
Nice.
And my eyes went to all of it. When you see those structures, do you just look at every connection? Like,
I'm a sucker for connections. So anytime I go anywhere, I'm always taking pictures. So if you look at my camera roll, yeah.
Oh man, you should text us all those.
I could for sure do that afterwards. Yeah. I'll go to like baseball, like the Globe Life Field in Dallas. They have a lot of exposed connections, so that's basically what I was doing all the time. Rather than paying attention to the game, I was just going walking around.
It's a boring game. Look around.
That's the best thing you can do as an engineer. Just pass the time.
Sure. Yeah.
I'm the same. I have a full, full enough pictures of connections.
With traveling internationally and studying abroad, have you found a country that does it uniquely? Is there any you're like, oh man, the UK, their connections are just wild or anything like that?
You know what? I haven't traveled international, but one of the things that I've seen are connections in Japan. They are very, very interesting connections just because of a lot of seismicity over there. So most of their connections, they're bolted connections. That anytime I see anything in social media about their connections, I'm just, impressed away by the.
Lately, I have seen some posts about Japan connections. I'm not sure why, but in LinkedIn, I have seen some pictures of Japan connections. Of course, it's a seismic area, so I guess. They're critical.
This must be a structural engineering thing because we have a friend that lives in Japan for a little bit and had shared a bunch of photos of connections 7 years ago,
and they only believe in HSS columns.
Exactly.
There's so much seismicity that they don't really lean towards yielding. It's it needs to be replaced and just elastic is fine. Yielding is a problem. But
and Mexico is also a seismic area, a very high seismic area in Mexico City actually, and you have that type of crazy connections there for bracings and so on. And I also, when I was in San Francisco, I was looking at the same type of connections and braces and it's great to look at the seismic connections. All
right, so my reason for my the clean connection question, I occasionally think, does software, when I use it, how do you make it so that engineers can make simple connections, not just tempt them if I click this button and add a stiffener, it works now, versus the logic of what makes this connection really good and clean in a nice way. Do you think software can help us simplify connections, or do you think we are making things sometimes more complex just out of habit?
I mean, software can offer both options. It's just a matter of how much time you want to spend on optimizing your connections. Whether you want to keep your connections the same way that it is, or whether you want to look at multiple other iterations that might help you either have faster erection time, faster fabrication time. It all depends. But yes, it can. A simple connection can become very complicated very easily if you so choose to. But the good thing about our software is that we offer multiple templates, whether you want to keep using your regular simple connections, or if you want to step away from that and make it more customizable.
And I'm probably we're going to that topic, but the way the connections are designed, let's say with this process of delegated connection design, it's the connection designer can do something, but at the end of the day, who has the last opinion is the fabricator.
Yes.
They're in control, really. I can optimize as much as I can, but if they say I need this
will be too much to
they just do it.
Yeah.
Right?
So I imagine you're getting a lot of feedback loops with structural engineers, probably a big portion of who you guys are interacting with. But like from a fabrication standpoint, do you guys hear feedback from the fabricators on new connections or things to adjust? And to the same point to architects at all? Like who are the main groups you guys are interacting with and what feedback are they giving you?
I would say we deal with all types. I mean, we've dealt with architects, detailers, fabricators, and they all have their own usage with Ideastatica, I would say. It's become a main tool for clear communication between all these different team players, I would say. Just because with Ideastatica, we have very, very good visuals and very good reports. So it just helps have that clear understanding between, the EOR, the connection designer with the fabricator. Like, rather than sending 2D drawings, they can send a clear picture of what the connection will look like, and then they can quickly tell you, hey, this is not buildable, you need to change this, rather than finishing your drawing, sending it to shop drawings, and then doing all this work for you to get a so it's a lot of faster process with our software.
Yeah, I imagine having a graphic is really helpful. Like that conversation is often not until a package is submitted, and then it goes out to bid for the connections, and the engineer is kind of detached at that point. But if you can just share a graphic of like, I'd like to build this, is this possible? And get to a better structure.
Yeah, you definitely get different usage from different stakeholders.
Yeah.
So that's very interesting for us, like learning what the fabricator is asking and compared to the structural engineer.
Yeah.
I imagine they have a lot of feedback that's like, hey, if they want to put stiffeners at 2 inches on center, just say no. Don't allow them to do that. And the software just pops up. Fabricator says no.
That would be great to have.
Some limitations.
Fabricator tips and tricks.
From a timing standpoint on design, we design the beams and the columns and maybe the lateral system first, and then we move to the connections almost last all the time. And it's probably often forgotten until weeks before the project's due. Is this a part of what you guys are finding quite often? Someone's like, hey, I need to get this done quickly. What's going on? And would you suggest, I'm going to take a guess here, they should probably start looking at those things sooner rather than later?
Yes. Sure answer is yes. But I mean, the way the country do connection design is different. Like from in the west side, you have this engineer that it's doing everything, so they can work early with the connections. But then in the east coast or east side of the country, you have this delegated connection design, which is so different, and they cannot be involved before, or during this structural analysis. So I'm not sure, how that can be changed, because that is something from the code that they require this delegated connections on.
Yeah. Spending most of my career on the West Coast or kind of more in the center. Yeah. I've never really experienced delegating connections and design.
I spent a little East Coast time. It was lovely. You just send a picture of the connection and they'll figure it out.
You're too strange to design for this loading.
I leaned West Coast first.
Yeah. And I think it made sense when I graduated school and started doing that design. It's like, well, it's high seismic. You want to have more control over how the system acts, right?
Definitely.
And maybe on the East Coast, there's still high seismic pockets and stuff, but having those connections delegated to me is just mind-boggling. So
it's weird.
It works.
It's weird. It's weird because you don't have control of the connections that are in your structure.
Yeah. Right. Yeah.
How you check that? It's real.
Sometimes I think it makes sense because we'll send like a double bolted or double angle bolted connection, to the fabrication. They're like, nah, we do shear tabs. And you're like, okay, design those. And they're like, you design them. And we're like, dang it. Okay. Redesign everything. So I think it kind of makes sense from that perspective.
Do you see the deferred connections moving at all? Or is it the East Coast does it this way, the West Coast does it this way? Do you see any change in that?
I think, but I cannot say I don't have one on the top of my mind. I see it differently, but definitely it changed the assignment.
What about the rest of the world?
Oh, yeah.
How does everyone else handle connection design? The world is.
I think, from my experience in Mexico, it's really different. And obviously, first of all, the like metric system.
Main topic.
That's different. Like here you have like this is what I learned. Like at the start, like the 3 inches is your regular spacing.
Yeah.
Right. It's kind of your rule of thumb. In the metric system, you want to find how do you say this? Like the same, like size from the top of the plate. How do you say? Like you have the same
Pitch distance?
edge distance,
Yeah.
Kind of like a centerline position, right?
centerline position. Yeah, there you go. So you do that type of design there. Compared to here, it's like
Top of steel.
top of
Oh,
steel.
yes, we do like these terms.
Yeah.
In Mexico, is it more deferred connections, or do they do the design? I wonder, in that side of things.
Yeah, they do. It's like
Full.
West Coast.
Yeah. Superior. I like this.
All right. This is often almost a cuss word in the software thing, the black box software. I hear a lot of older engineers talk on like, this doesn't give me an output. Like this is, I don't know what's going on here. It's black box software. How do you juggle, like, there's a lot of checks that go into a complicated connection. Static has really nice outputs, but how do you juggle, like, what is provided to the engineer of like, here are the checks that are done versus the software doing a lot of stuff anyway? Like, that's a hard line, I imagine. What do you think of this?
I'd say one of the main things that we try to push for are kind of having a clear understanding of what Idea Statica does. So by doing that, we do a lot of verification work. So unlike many other software that will just release, their new products, with us, we try to verify our applications before we release it. So, just to ensure that we're aligned with the code, whether that's through comparing it with other advanced analysis or real experimental work, which is what we do with different universities here in the US. So that's something that we try to push for so that we can be seen as rather than a black box, an open box.
Yeah.
Where if they have any questions, they can always go through our research and see how everything is verified. But aside from that, I think we do a very good job on our reports.
Yeah.
We try to...
I agree.
We put everything, whether it's the code checks or the theoretical background of our software. That's some of the main things that we try to push for. And of course, we always try to educate our users, and we try to release content to better help them verify their work. So one of the recent one was an EOR checklist. So we released an article for EORs that they can use.
Yeah.
Kind of a step-by-step on what to look into Idea Statica reports and how to verify that it's a
like that.
Good quality.
Yeah, because for the delegated connection design, you don't have the software. You're just viewing reports. So they cannot look at the form shape or how that was modeled. They just see the report.
Yeah.
And if you see it, it's like as any other report, right?
Yeah.
You need to learn what's there. And so that we are also doing this education for the checkers or reviewers, which is kind of our responsibility a little bit with our users, so they feel sure that they are delivering something, and the other person knows what is there, right?
So we try to tackle all fronts, whether it's the end user or whoever's checking the results. If it's the end user, we try to educate them on how to best use the application, what not to do, or what you should do, because with any software, anything you put in will give you any results back. So you want to make sure that they're doing it correctly, that they know how to read the outputs, and ensure that whatever they modeled and the design is correctly being presented.
Yeah, that makes sense. I mean, I think ultimately the responsibility is on the engineer, right?
Exactly. So
they got to put the good stuff in, validate that it's right, and that the results look good to them.
Right.
Walk us through I think we've talked about this a little bit, before this, but the university side of thing, the collaboration with professors and research. Can you walk us through that a little bit more?
Yeah. So, the software has this kind of different methodology of what we are used to, to design connections. So when we started the branch here in the US, we wanted the users to be sure that what they are seeing or how is our methodology that we call it CBFEM. So Idea Statica started to collaborate with different universities to do, comparing idea-static results versus traditional methodologies. So that's basically the work that we have together with these universities. If you go to our website, we have this catalog of limit states for connection design. So basically, you have a list of all the limit states that you will check in a connection, and then for each of these limit states, we have a verification study. That's how we call it. So these professors and some PhD students were comparing idea-static results to
That's
those.
nice.
So. I mean, for the shear tab, it's easy to compare, right? But whenever you have a shear tab in the node where you have multiple members coming in,
it gets a little wild.
Yeah, so it's basically extrapolating the simple stuff to a complex node.
Yeah, and that also like speaks on the black box concept. Like you can't, I don't know, having papers to discuss every check that you're providing is a big value. And like, wait, this is what we're looking at. So,
yeah.
What would you say if you got to stand in front of the room of 6,000 young structural engineers? What would you tell them about connection design? What do you commonly get questioned about? What do you wish they knew? Okay, 7,000 structural engineers.
7,000. That's a lot. All right. So I'll say. I'm thinking like in a way like you're talking to young engineers, right?
Yeah, right.
So whatever you're putting in your assumptions, let's talk about the structural analysis that you're doing for like the main structure, let's say. So you go into your software and you're saying like this beam it has a pin end or a fixed end, right? So that is only an assumption.
And very binary. Like you get one or the other.
Yeah, exactly.
Everything is actually in the middle.
Yeah.
So that doesn't exist in real life, all right? So, but that helps us to do a structural analysis, right? That is a tool only. However, this value that you're selecting for that end of the beam needs to be translated into a connection. So that's basically what you're doing with the connection design, right? So that's how I explain like connection design to students if I need to. So with depending on what type of connection, that's how you're defining this condition in your beam. So probably that would be my
yeah, just like she said, just make sure you design as intended. If you design a pin connection, design it as it should. Or if it's a moment connection, just ensure that it's able to transfer, those forces. And eventually, you don't want to be responsible for any catastrophe. So just make sure it's designed correctly within the constraints and the boundaries that you've set.
I like it. I have some questions on the future, if you can help me here.
Let's go.
So you talk about the future of connection design, right? Our industry evolves and it keeps changing. I've heard structural engineering is moving slower than the rest of the world, economic side. But like, what changes have maybe you seen in your career, and what do you expect connection design and structural engineering to look like in 2030, the end of your career?
My hopes will be that connections will be more complicated.
It does sound lovely.
Not in a bad way, but as we're advancing and as we're moving more into the future, I would hope that we are able to tackle more complex projects, being able to make more intricate designs, whether it's building or my favorite thing, shade structures.
Yes.
Not just keeping on the basic norms of do this shape and stick to it for the rest of your life. Try to think of innovative ways. So
and this shape and stick with it has been what structural engineering has been. Like I was referencing a table, you look at how many bolts the beam has, like confidence in analysis.
Exactly. So feeling free to step out of the norms. Be exposed to some new things. That would be what I would hope for the future.
I like it.
I guess with all this AI thing.
We have that.
Yeah. So I'm not that fan of AI. We have seen because it's just, as people say, it's just an LLM. right? Large language models. So it's not that smart for me.
Typical engineer response.
So, but I guess that there will be tools to, like kind of optimize to help you to not do this from scratch every time.
Yeah.
And help us to save time. Because honestly, they'll never get rid of engineers. No worries. They are not getting our job.
Someone needs to be liable.
Yeah, exactly. Not a computer. Right? So I guess my hope is that we get into that phase where we really can save a lot of time. Like not doing everything from scratch. And I believe with Idea Statica, we're like kind of going to that side of things. But it's coming.
Yeah.
Right?
Yeah. We've been so curious with AI and have been testing it and trying it. And some days it's like, wow, this is phenomenal. Like, this is going to change everything. And then the next day the answer is so wrong.
You're like, hallucinations.
What happened here? And it's just mind-boggling. To me, I think the future, especially with connection design, is some iteration between the structural engineer and the fabricator, being able to go back and forth a little bit more. I have this idealized project in my head where it's more design build, and that all the builders are at the table with you while you're designing your building. It's impossible, but I'm hoping AI helps drive that a little bit of like, here's our design. How do you want to adjust this? And that can help.
That's kind of our idealized utopian world for this. So being able to have, Idea Statica where we can, quickly share the model or share the entire project with the fabricator. They can quickly see what's going on, or with a detailer so they can grab those, already model connection and import them quickly to their detailing software, or sending your entire batch report to the EOR and they can quickly see it. So having a tool to have clear communications, I think that's where...
But stay tuned.
Stay tuned.
We're making progress there in Idea Statica. So probably we'll come back with you guys and you'll see it.
You'll be the first to know.
Well, to wrap us up here, is there any questions that we haven't asked that you guys think would be really important for our listeners to hear?
Oh my God, you ask a lot of...
Let's see.
We so often find as we ask these open-ended questions, people go places we never would have thought of. So
yes, no, it's...
let's see.
I'll say from my point of view, from all the topics that I speak today or I talk today, is be open to whatever is coming to your career. Let's say, do not think like from my experience. Do not say like working in a software company is going to kind of downgrade my engineering skills. Not at all. It is not the case, right? But you can say that with other type of industries, maybe, right? So just be open.
I would say just be a sponge. Be open to any learning opportunities, whether it be from your managers or any other departments that you work in parallel with. Just be open to feedback, and don't be afraid to ask questions, and also don't be afraid to step out of your comfort zone. That's especially basically what we did, going out from your typical engineering into the software world. You don't really know what to expect, but turns out it's awesome.
That's a great review.
Awesome. Well, thank you both so much for being on the podcast this week. I know Max and I have learned a lot, and I bet our listeners will too.
No, thank you for having us. It's been a pleasure.
Thank you so much.